Well, good morning. My name is Beth Sanders. Thank you so much for joining us today. I'm the Vice Chair of the Registrars Committee Western Region, and we're the regional affiliate for the Collection Stewardship Group of AAM. We're so glad to bring you another webinar in this series that has been so fun for the last year, hands-on practical conservation for the collections professional. Our sponsor for today's webinar is Gander & White. Gander & White Shipping has been handling fine arts and antiques with the utmost care and discretion for over 85 years, providing shipping and installation services to art dealers, private collectors, and museums around the world. With locations in New York, London, Paris, Miami, Palm Beach, and here on the West Coast in both San Francisco and LA, be sure to contact Gander & White for your upcoming projects. And a big thank you to Gander & White for being a Tier 1 sponsor of RCWR. If you're not a member of RCWR, let me request that you consider joining today. As I said, we're the regional affiliate of CSAAM, representing our 9 Western states. With membership being only $15 a year and bringing you great programming like these webinars, as well as in-person events in the near future, but also a weekly job listing email, a quarterly newsletter, and stipends for regional and national conferences, it's a really great deal. So to learn more and join today, go to rcwr.org. A few quick logistics before we get into the main body of the program. Since this is a webinar format, we can't see you, even though you can see us speaking. So I hope you're comfortable, whether you're having a cup of tea like me or a cocktail if you're in a different, no matter what time zone you're in, no judgment. Feel free to stay comfortable. But we do have 2 features in the Zoom format, the chat that several people have already been saying hello and good morning, introducing themselves. Use that and make sure to select whether you want to send your message to just the hosts and panelists or to everyone. So if you want to make a comment about something that you're hearing, feel free to put that in the chat. But if you have a question, please put that in the Q&A feature rather than the chat. And that will actually compile all the questions for me to ask to our presenter at the end of the topic. So that way I'll be watching the chat, but I might ask you to put it in there if I see a question listed. Today, we are very fortunate to have another great presenter, Özge Gençay Üstün, here with us. Özge has been intrigued by the testing of heavy metal pesticides on artifacts since her internship at the National Museum of the American Indian. This shaped her master's thesis at UCLA's Getty Conservation of Cultural Heritage program, and later her profession at the Autry Museum of the American West. Since 2013, she's been on the team for the Alalach Tel Atrana, I apologize if I messed that up, excavations, a Middle Bronze Age archaeological site. And she loves to share her conservation and preservation skills in these multidisciplinary settings. She's interested in preventative conservation, specifically ODI testing for creating safe enclosures for both housed and exhibited objects, environmental monitoring, and integrated pest management. Özge is always curious, solving conservation-related problems using analytical tools, and we're so glad to have her here with us to talk about hazardous materials in our collections. With that, I'm going to stop sharing my screen, and we'll turn it over to her.
Hi, everyone. And thank you, Beth, and thank you, Beth and Registrars Committee Western Region for facilitating this workshop. It has given me the opportunity to what I like to do the most. I love taking care of collections and also talking about my experience in museum work. I'd be happy to be helpful to museum colleagues in any way that I can, so don't hesitate to contact me. And I'm going to share my screen with you so that I can start the presentation. Okay, hazardous materials in collections. Before I start, I would like to acknowledge the Gabrielino Tongva peoples as the traditional land caretakers of Tobangar, the Los Angeles Basin, and the Southern Channel Islands. I pay my respect to the Honuek Vetam ancestors, Ahi Hiram elders, and Ayo Hinkem, our relatives, past, present, and emerging. And I wish to provide care for this land under their guidance. First, I will talk to you about the content of this workshop. It's presented in two parts. First, I will identify most common hazardous materials in museum collections. While doing so, I will talk about some examples of risk management methods that are chosen for specific objects. Then I will talk about a case study which will walk you through the steps I have gone through at the Autry Museum for pesticides presence, as it is hazardous to humans as well. In this section, we will talk about how we determined the objects that may carry hazardous substances, what to look for. Then I'm going to be talking about how you might choose to manage your collection with these hazards at hand. And then end the talk with about personal protection and guidelines to handling these collections. So first things first, National Parks states that a hazardous material is a chemical or mixture of chemicals that is toxic, highly toxic, an irritant, a corrosive, a strong oxidizer, a strong sensitizer, combustible, flammable, extremely flammable, dangerously reactive, pressure generating, or that otherwise may cause substantial personal injury or substantial illness during or as a direct result of any customary or reasonable foreseeable handling or use. So what are these possible hazardous materials in collections? These include historic objects that include asbestos, some pigments with heavy metals like lead, mercury, arsenic, cadmium, and objects made with mercury as well. Natural history specimens, which include animals preserved in liquids, animals or part of animals like their skins, stuffed with preservatives. Biological hazardous materials include mold, insect excrements, bacteria. Mineral specimens, which may also include hazardous heavy metals and or radioactive materials. There's also historic collections that include chemical, medical apothecary sets, cellulose nitrate film, firearms, and finally pesticides used in museum collection areas. These hazards may be found on objects or in collection areas too. Determine the location and the extent of the hazardous materials to understand the scope of the risk to manage these collections. Collections might be hazardous by nature or design, so it could be included during the design of the manufacture of the object or by nature like the minerals. I may not cover every single object in museums, but this is mostly what one might encounter in general. Asbestos was used as a heat insulator in the past. It was used in anything that involved in heat, such as lamp fixtures, TVs, and all sorts of electronic equipment that produced heat. So asbestos was used to prevent flames coming out from extremely heated sources to protect people. As you can see on the left, safety first, the motion picture machine in this theater is enclosed in an asbestos booth, absolutely fireproof. Asbestos was also added to art plasters and stuccos used for decorative works because it was cheap and found it was plentiful. You can see in the middle, there's the mineral that includes asbestos in it, called tourmaline. However alarming, not all forms of asbestos is hazardous. It has to be friable to be hazardous. The object in question may contain such small amounts of asbestos or in forms not easily converted to airborne fibers, non-friable. That means the risk from the product is likely to be very small. So there's this suit on the right with asbestos in it to protect it from fire, to protect the wearer of the suit from fire. One might elect to dispose of an old asbestos-containing toaster but not to hire an environmental test firm or asbestos abatement company for that procedure. And for example, that suit was enclosed, encapsulated in a plastic bag and housed on its handling board, to prevent the handlers from contacting the asbestos. Some pigments containing heavy metals include lead, cadmium, mercury, arsenic, and these are found in pigments. As you can see on the pictures, lead white has lead, and minium, the mineral, has it's red and it has lead in it. Cinnabar mineral also contains mercury, and it has been used as a pigment in artwork. And realgar pigment contains arsenic. They may come in various different colors and even greens and yellows too. These pigments might have been used to paint areas where the collections are housed. So they were used in historic houses before they were known to be, for example, the lead paint, before they were known to be toxic. One should be careful, as these might cross-contaminate collections if they tend to be powdery. They could be also found in artworks incorporated due to their appeal, such as coloring. So naturally, by design, these paintings might include these heavy metals due to the pigments, the colors that they produce. Depending on the nature of the paintings, these may or may not be hazardous. The hazardous level will be different if these powdery pigments are well bound within the painting, as opposed to deteriorated binding media, causing the powdery pigments to flake, spall, and detach from the substrate. Thus, they may be airborne and carried within a museum and carried to the user. Objects made with mercury include this one on the left, the image on the left, a thermometer from the Science Museum in London. Solid mercury can be found in these thermometers, and they are safely housed as long as there is no leakage from the glass. And on the far right is a mercury mirror. Mercury was used in the manufacture of these mirrors during the 16th century as a reflective characteristics, and it was stopped to be used in production of these mirrors in the 1840s, switching to silver nitrate. During the conservation of such mirrors, beads of mercury are found on the frames, and these may fall off, contaminating floors and polluting indoor air with mercury vapor. Not particular this mirror, but they were found on other mirrors. And as we all know, the image on the middle is a hat made with mercuric nitrate. It was used to treat the fur of small animals for the manufacture of felt hats in the 19th century. Mercury was also used on silk to weigh the silk down. So these may contain hazardous materials. Natural history specimens. Arsenical soaps and mercury chloride were used in taxidermy collections in the past. They were stuffed with large amounts of powder of these substances. And formaldehyde, which is a carcinogen, is used to preserve some animals. Tissues and internal organs were also housed in these liquids. In natural history museums, as well as contemporary art, one may find formaldehyde. And it enters the body through inhalation. And the picture on the bottom shows the contemporary art by Damien Hirst, entitled "The Physical Impossibility of Death in the Mind of Someone Living." The shark is in a tank, a sealed tank with formaldehyde. And in the past, there was a problem with it. It was exhibited in a museum where they figured out that there was a leakage, so they had to shut down the room for a couple of days until they figure out how to seal it back again. Biological hazards include mold, insect excrements, and bacteria. Mold is the common term used to describe a furry growth on the surface of organic matter caused by fungi, especially in the presence of high relative humidity of the environment. And those are like damp areas or areas that have like really high humidity. And they grow in 24 hours. So like if something is wet for more than a day, mold might highly likely to grow on it. They eat on starch, protein, and cellulose, basically most library materials, along with some museum objects that have leather, wood, fur, etc. It can cause deterioration on objects, as well as discomfort and some illness in humans. Insect excrements include rat droppings, carcasses of insects, and casings of insects. They may or may not bother people, depending on, and rat droppings are known to be poisonous too, hazardous to humans too. And bacteria, these are unlikely to be found in museums, but can be found in archaeological sites and possibly museums carrying these archaeological collections. There are concerns in excavation sites which are related to valley fever, rabies, hantavirus, and Lyme disease. And mineral specimens and chemical medical sets. The one on the left shows all the most of the mineral specimens that have above said heavy metals: lead, arsenic, mercury, cadmium, asbestos, silica, and even radioactive materials such as uranium, radium, which are hazardous to human health. Depending on the state of these ores, they can cause acute or chronic diseases and should be handled, stored accordingly. And the image on the left shows a apothecary set that has like chemical, it is a chemical set, a medical set that may be hazardous to humans because the medical sets that are found in them can have like mercury tablets, concoctions with arsenic, and controlled substances. And yes, these remedies were once used on humans for ailments because the hazards were unknown or not understood well. And cellulose nitrate film found in collections, mainly archival collections. Celluloid was first manufactured by George Eastman in 1889. It was used as a base for photographic roll film, professional 35mm motion picture film, and X-ray films until the 1950s. But this date shouldn't confuse us because it was used well after the 50s, as these films were still sitting around. It is highly flammable and also decomposes with age, becoming toxic. So the one on the left is a cellulose nitrate film in excellent condition, and the one on the right is a deteriorated cellulose nitrate film. Nitrate film yellows and curls as it deteriorates, and it produces a strong acrid odor. The smell of nitrate film deterioration can be distinguished from acetate film, which is now used deterioration, known as vinegar syndrome, after its characteristic vinegar odor. Otherwise, to the untrained eye, nitrate film is often difficult to distinguish from other non-flammable photographic films. Assess the risk of nitrate film by investigating the whereabouts and quantity of nitrate in the building, the condition of the film, the importance, significance of the image material, and the resources available or required to manage it safely. Find ways to reduce fire risks from stored nitrate film, such as ventilated flammable material storage cabinets. And I mind you that very low temperatures are needed to stabilize these films, and have an emergency preparedness plan as well for nitrate films if you're housing them in your museums or collections. Ensure the risk assessment for using and keeping nitrate film is shared with everyone likely to need to know about it. It's good to know for other people to know about it, and the emergency preparedness plan as well. Museums can eliminate the hazard by digitizing and transferring nitrate film to another organization that can store them in sub-zero temperatures. And some museums have firearms. We had like most of the above hazards at the Autry, and firearms was one of them. As they're hazardous depending on the ammunition they use. It can be explosive and threat to humans and collections. We had on top of our fire drills, earthquake drills here in Los Angeles, we had a active shooter drill too. And the collections manager who is taking care of the firearms had also been notified, because it's that's the person who is taking care of or keeping the locks for these collections. They should be, depending on their nature, because they should be kept locked in locked enclosures and inspected regularly. They should be disarmed as well. Ammunition and the firearms are kept separately. And there are institutions like the ATF, Alcohol, Tobacco, Firearms Agency within the Department of Justice that license and inspect these collections. And finally, the pesticides used in museum collection areas. And I will talk more about this because that's what I did at the Autry Museum. And pesticides included heavy metals and other hazardous substances were used in Natural History Museum and indigenous collection areas in the past. So if you have a museum with these type of collections, know that there may be some sort of pesticides applied in the past. We had a good number, as I said, we had a good number of hazardous collection and areas at the Autry Museum. We had a lead, a collection, a museum area with lead paint. We had asbestos room where we kept our archaeological stones and pesticides. But today I'm going to talk about only the pesticide issue that we had. And the following slides will be about this case study to show you how we managed this hazard at the Autry to eliminate risks that may be caused by objects that are unintentionally contaminated with these substances. But first, let me walk you through our thinking process with this one slide. So hopefully I haven't bored you to death. I can see you guys, but let me talk to you about how we first identify the hazard. How can you know specific objects might carry any hazardous substances? You got to know your collection well. You may be managing a collection of couple thousand or 100,000. Don't fret it if you don't know well all of them well by heart. You're not alone. Just acquaint yourself with possible hazardous materials. There may be one or two odd things you'd never think about. Some might be already in your database, thankfully. If you have doubt, just do simple research on the internet or use the resources suggested in this presentation. If in doubt, set aside the object or artifact and ask a conservator. Basically, look at the manufacture date of an item. Before the 20th century, not many materials were known to be toxic, so they were used freely, even the pesticides. In addition, get yourself acquainted with hazardous materials. I cannot stress high enough that part. And as I said, I may not have covered every single odd object in this workshop, but the most hazardous materials that your collections may come with is covered here. And then assess the risk. What is the condition and nature of the hazard? In what state is it found? How hazardous is it? What is the emergency? How urgently you must act depending on how you use these collections. Then I will show how we took action. Do we remove the object in question? Do we isolate it, encapsulate it, or take a different approach depending on the collection's needs to be accessible for everyone? Then in the last part, I will talk about educating included parties, that is like Native Americans for us, as well as museum professionals, and prepare for guidelines and handling these collections, and urge handlers to use personal protection equipment. These substances are called pesticides. In general, they can also be called the umbrella name biocides. They are also called fungicides, herbicides, insecticides, and these have been used to prevent, destroy, repel, or mitigate pests in order to preserve museum collections. These chemicals are also known to be toxic to humans in various capacities. They come in many names. They can have trade names, chemical names, synonyms. The types of pesticides used in the museums include inorganic pesticides that contain heavy metals. As we discussed, these are highly toxic to any living creature. They also include organic pesticides like the well-known DDT. These are usually volatile. Their poisonous byproducts may not readily be decomposed, so they may still be present on objects. We first learned how to determine the presence of these poisons in our collection. Then, to understand how these work, we looked at the historic uses of these substances. We carefully examine our objects, inspect the collection, look for powdery, white crystal deposits for arsenic and DDT in the crevices and seams where dust may have collected. If one is in doubt, we recommended people to consult a conservator. If the object is very old but in a good condition, suspect pesticides use and possible contamination. Feathers and furs are usually susceptible to pest infestations, and if these are in very good condition, and if they are very old, then we suspect that they might have sprayed with pesticides at some point of their history. And then we learned about the history of pesticide use in museums to understand the state of these chemicals. During our research on the history of pesticides use, we learned that pesticides used in museum was adapted from taxidermy preservation techniques. We also learned that even though these chemicals were banned at some certain dates, they were still being in use way past these dates, because they were already bought sitting in museum storage areas. Some of these hazardous chemicals have also been approved to use as a museum fumigant by the EPA, Environmental Protection Agency, since 1981. Applications involve dusting, fumigating, spraying, and sometimes shoveling chemical concoctions onto artifacts. During our research in our museum, we also found that there was a barrel with a liquid where textiles were occasionally dipped in. And these are in quotes that we found from our museum memos. And we suspect that these textiles had arsenic. This barrel had a concoction of a liquid contained arsenic, because we were finding, we were analyzing some textiles and finding arsenic and lead. How do these pesticides work? To assess the risk, one needs to look at the working mechanism of these poisons. How do these poisons work to kill pests? They enter the organisms through their respiratory systems, through inhalation, digestive systems through mouth, ingestion, and dermal contact through skin. Pesticides may be airborne and contaminate other artifacts in the vicinity. Some volatile pesticides may be persistent and attached to the objects. They may still volatilize within the museum. For example, the smell of naphthalene, and we know that it is toxic to humans. And we can still, in the museums, we have this granny cupboard smell. These objects are not only accessible by researchers and museum staff, but also by tribal members in our case. Humans are living organisms too, so they too will be affected with these poisons. To assess their risk as they are found in museum collections, the mode of entry of these toxins to the human body is important. For example, elemental mercury is not acutely harmful when entering the body through ingestion. So if you, but collapses the respiratory and nervous system when inhaled. So if you break a mercury metal containing thermometer, you air the room, you just get rid of the vapors from it. And lead does not enter through skin, but enters the body through the mouth. Because lead is like huge, big particles, so it doesn't go through the skin, but it goes to our bodies through ingestion. The emergency, why we needed to attend to this problem immediately, apart from the fact that these were housed and handled by museum professionals and researchers. These included NACPRA objects being returned under the Native American Graves Protection and Repatriation Act. In 1995, during a consultation at the Harvard Peabody Museum, the Hopi had found out that Hopi friends in this museum were contaminated with arsenic. So people have started to look into ways to determine these pesticides used in the past. These items go back to communities where handling the sacred items occurred extensively during initial cleaning, repair, and preparation for storage almost daily during their long-time care. Storage places used by most family members, from newborns to elders, in varying sizes of people. These storage areas were underground ceremonial chambers that were overcrowded and had no ventilation. And storage areas were along with houses where dry food was kept and daily activities took place. NACPRA amendment gives the museums the responsibility to report on pesticide treatment histories. And most importantly, by these tribal members, it was expressed that there was no recognition of the educational needs of tribes who would need to interpret and the technical information that one might get in museums and institutions. So as museums, we were responsible to look further into the problem. It was decided that toxicologists and museum health professionals should be involved to assist in determining safe levels of toxic inorganic substances found in these objects. Institutes and museums do scientific research on the issue. They're looking for ways to mitigate the risks on the tribal museum side as well. So we prepared workshops to share how we handle the issue with the tribal museums in conferences and during consultations. First, we needed to detect these hazards. In order to determine the presence of these chemicals, institutions started analytical testing on the side of visual inspections. This testing involved sampling in some cases, so other parties involved in this process, as some of these collections belonged to the communities. And we didn't sample because sampling required contacting with the tribal members. Also, it was deemed to be invasive. These are living items for these tribal communities, so we had to respect that. And also sending these samples to specialized labs is expensive. Not all museums and institutions can cover those costs. But many museums had portable X-ray fluorescence instruments that we could use without sampling. And it was mostly approved by tribal members. So we mainly did visual inspection, some spot tests, and portable X-ray fluorescence. Then we prepared documentation that interprets these analytical test data to report to the owners for the repatriated items. We prepared detailed reports for repatriations. The one on the right shows those one of the detailed reports. But internally, we entered the analysis results to our database in short format. Then we educate ourselves and others. We communicated how to determine pesticides presence on artifacts. So consult a conservator if you cannot decide. And toxics inventory of the collections should also be made. And this requires extensive research on the collection's history and the museum's collectors they had gone through throughout their lifetime. Implementing personal safety guidelines for handling contaminated artifacts for everyone in contact, and we made them accessible. And then we asked tribal members to permit institutions to do analysis on objects and maybe even sampling to further our research. If not known whether the object is contaminated or not, handle as if it is contaminated. That's what we did in our museum. So we had to move 300,000 objects from one site to another site. And that project involved many people handling these objects, taking them out of their cupboards, inspecting them, entering them on the database, photographing them, and cleaning them, and creating safety handling trays and housing to prepare for moving, and then move them finally into our new storage space. So this whole process involved in many people handling, looking at these artifacts, and also we had consultations during this process. So we enforce guidelines for everyone in contact with the contaminated objects and the room that contains these collections. And we keep a clean and separate environment equipped with personal protection equipment. So we prepared these guidelines, and I'm going to walk you through the guidelines we went through during a 5-6 year period. Keep the objects separate. The collections room and the kitchen should be separate, kept separate. Food and drinks should be kept and consumed away from these collections. Keeping the objects separate, the cabinets should be labeled to indicate contaminated surfaces and objects, and separate them from collections, from other collections, so that we could prevent cross-contamination. Keeping the equipment and environment clean, separate and mark pencils and notebooks and notepads for use with contaminated objects. And it is what we do now with the new COVID. We go to doctors' offices, restaurants, and we see these boxes full with pens that says sterilized pens and used pens. So they separate the pens so that we don't transfer our viruses to other, the spread of COVID. And they could be saved in a container with proper labels. Caution, handle only with gloves, and cover the surface of the table with a disposable paper, tissue or blotter paper, which is discarded outdoors at the end of each workday. We found that to be unrealistic, so we covered the surfaces with polyethylene, ethafoam foams, or plastic because we could wipe them off easily at the end of each workday. Keeping the equipment and environment clean. Don't handle cameras, cataloging tools during examination unless these tools are marked and separated. Determine any personal property, tools, or equipment that you want to keep clean and touch with bare hands later, so keep them separate. Don't expect to touch your cell phone, stereo while you are gloved or working with contaminated objects. If you must use your keyboard or anything else that can't be wiped down later, cover them with a disposable HDPE liner which is a basic trash bag, which is discarded when you are done with the contaminated objects for the day. So know your PPE, personal protection equipment. Do you know what to use, when to use? And this image was shamelessly gotten stolen from the internet. And this is a picture I took from the Field Museum, where they keep their lab coats, clean lab coats. The buckets contain the dirty lab coats, and these are the hung ones are the clean lab coats. And this is an area where they wash and dry the lab coats that they use and clean weekly. And we had the similar setup in our premises. Wash hands with soap and water before handling collection materials. Take off rings as they may collect dust or tear the gloves. Wear nitrate gloves. We didn't use cotton or latex. Cotton was permeable to dust. Latex can cause allergic reactions, and we don't use gloves with powder in them. Wear a buttoned lab coat and wear an N95 mask. And we all learned about N95 masks. These are National Institute of Occupation Safety and Hazard health compliant N95 masks. Don't get anything else that doesn't say N95 or NIOSH compliant, because they're not always compliant with the US standards. The other ones, the K95s, I guess they're called. N95 masks filter 95% of particulate matter if used properly. So you need to keep a good seal around the edges of the mask to your face and shape the metal nose band so that it pinches snugly around your nose. And if necessary, you might need a fit-tested respirator, which I would doubt that, because if you do need that, it would probably be because you would be in a room with asbestos or similar hazards. So I don't think you would necessarily be doing that. And if possible, handle objects by their stands or mounts. While wearing personal protection equipment, break everything down to clean versus dirty. Keep hands away from the eyes, mouth, and nose with gloved hands. Examine objects in a well-ventilated room. Do not touch door handles and phones with gloved hands. If you need to touch them, you can just discard the gloves, touch them, and wear new sets of gloves. Only touch areas where surfaces are cleaned periodically, such as drawer handles, the container with pencil and notepads, and lab coat. Do not drink or eat in the room during examination, and give breaks to drink water if you need to. So take off your gloves, drink your water, and get a new set of gloves and wear them. Do not chew on pencils or glasses. Objects can be vacuumed with HEPA filter vacuums. These vacuums can have attachments. The one on the right, you can see there's a little attachment here for variable vacuum pressure in order not to harm the object. And then there are different tips you can attach here instead of this floor sweeping tool. You can like have small nozzles to clean objects in like small areas. You can also adjust the suction speed. This is where you adjust the suction speed. And also they are equipped with high efficiency particulate air filters so that the exhaust does not include particulate matter from the object. Everyone has to have consistent practices for good hygiene to prevail. And before taking off your gloves, Wipe clean any surface touched with gloves or object, storage cabinets, carts, brushes with wet wipes. Wash all vacuum brushes. Here it says Nilfisk because it's a brand name that we use. And it is the brand name that comes with attachments. Nilfisk brushes daily with soap at the lab sink. And for photography, each day vacuum the photo paper. At the end of the entire basket project, throw out the paper. Same for ethafoam on the carts. Since we are reusing the lab coats for a week, we follow this sequence to keep the inside of our lab coat clean. So when taking off, removing our PPE, we took off the gloves first without touching the outer surfaces with bare hands. So I forgot to bring my gloves, but like you just like touch the outer surface. Do not touch your hands with gloves still on them, and then you can just like swiftly take it off and dump it in a trash can. Then remove the mask and then take off the lab coat and wash hands immediately with soap. So we put our lab coats inside out on our chairs, and that's how we kept them clean. And then weekly we wash them. Lab coats are changed weekly. There was a designated area to deposit them so that they would be taken the next day for washing. We minimized the extra laundry created while still maintaining good hygiene. We kept our own, like if we needed blankets, because our museum was so cold, some people needed blankets on their labs. We tend to not to use them to minimize laundry. So these cautionary steps may look excessive, but we managed to go through them. We left the conversation open with our colleagues to understand, assess, change any parts of these guidelines. We provided readily available resources that we can consult. And remember to include your hazardous materials in your emergency preparedness plan. And conservators are not health and safety experts, but we can provide some resources that we know of. And then personal safety comes first. So get yourselves acquainted with these hazardous materials. I provided some bibliography with resources. Check with OSHA and EPA. They can provide safety information. And I urge you to, just a second. I urge you to go through Museum London's electronic tool, Hazards in Collections, the website that I provided. It gives all sorts of items that may be found in museums that have hazards, that are hazardous. And also, I'm sure you are all aware of the National Park Service's very helpful publication, Conservograms. If you go to their website and search for anything like hazardous waste or mold or any specific word, you'll find what you're looking for. The Agency for Toxic Substances and Disease Registry is a federal public health agency within the United States Department of Health and Human Services. It focuses on minimizing human health risks associated with exposure to hazardous substances. And there's also a conservation wiki on hazardous collections, devoted basically on hazardous collections, and I provided the website. And thank you for listening to me.
Thank you so much.
I didn't take too much of time and have time for like questions and answers.
Yeah, we have time for some questions. Do you want to leave your screen up or stop your share?
Oh, sorry. Thank you for reminding that.
Well, we have a few questions that came in. And I encourage everyone to put their questions into the Q&A feature and we will get them asked to Özge. I do want to note that I dropped a link into the chat just a moment ago if you needed to reference back to any of those resources that were just put on the screen. We are recording this webinar and we will be posting it in the next few days to our YouTube page. So go and subscribe to our YouTube page and you'll get a link, notification with the link to that. But we do have some questions coming in. The first one is about when repatriating objects that have been contaminated. We talked about some of the things that the tribes can do to mitigate the harm with handling these objects, but they have a set follow-up question. Are there any methods available to remove these poisons from the objects?
Not yet. We are working on it because, I mean, since these objects are can be friable, they're fragile and they involve tribal consent, and they had to go through so many experiments to be safely removed without harming the objects. So conservators are still trying to get rid of these, to learn ways how to get rid of these chemicals off of objects. So that that's the main goal. I don't know how achievable it is, but they're trying. Some conservators are still like trying to find ways.
Hopefully in the future.
Yes.
We have another person who's would love more information on identifying hats that have been treated with the mercuric nitrate. Are there any recommendations on the best way to do this? Or I would expand that as myself of identifying any felts or materials that have been treated with this.
So I haven't personally researched into that, but there are test strips that one can use. Mercury, I think there are mercury test strips. You can just like swipe on top of the hat, the surface of the hat, and depending on the indicating results, you either have or not, like follow the instructions on the test strips, and indicating results will show you whether you have it or not. This is the least expensive way to find out. And I should include a resource that does spot tests, gives the instructions on how to do spot tests for like specific materials. It can include plastics or other materials too, but mercury was one of them. I think you can do spot tests, and this is also another, but you have to buy chemicals in order to do analytical analysis with the samples from the hats. And another easy way is it's expensive. Some museums have portable X-ray fluorescence instruments, so you can just analyze, like you can point and shoot and look at the numbers that the analyzers give. And if you find someone, I'm sure the conservator will help you figure that out. They might not lend you the instrument, but I don't know, find a ways to bring the instrument and the object together so that they can analyze.
Perhaps it's a great opportunity for collaboration with a local university.
Yes.
That would have the equipment already and students that need projects to do.
Yeah, true.
Kate asks if all museums with firearms are required to be inspected by the ATF.
I'm not sure about that. Our museum was definitely doing that. Like each year, that one person who kept the lock, the keypad to the lock, had to go through their like regular seminars, and yeah, it's just like sitting in a seminar. And then I'm not sure how often they came, but I can give you the name of that person and in our museum, and then they could help with the procedures, how to carry out, and have more information about that.
So that might be a great one, Kate, to follow up with an email.
Mm-hmm.
And you can get more information on that contact person. From my experience, I work for the Navy. We don't have our collections checked by the ATF, but we have a lot of other regulations. So I'm very glad that we have no small arms in my collection. But we do have torpedoes, so different.
And California has like more stricter regulations in general.
You mentioned that you wipe down the ethafoam each day. What are you wiping it down with?
We use just general wet wipes. There's a brand called Lead Wipe and D-Lead soap. So it's supposedly cleans more efficiently than a regular soap. But they did research, and I think regular soap just works fine as long as you wash your hands 20 seconds, which we have been doing for the past 2 years.
Earlier, you mentioned the asbestos storage area at the Autry. Are there any materials that it's not best to store in concentrate?
So the asbestos storage area was like the area had asbestos in it, and we happened to store our stones in that room. And then this was at the Southwest Museum, by the way. It was founded in 1900s, and the room was had to be insulated, so they used asbestos in it. But without knowing this, way in the back, they said, oh, we have a room here, let's store these stones, archaeological stones here. So they put the stones there, and in order for us to move them out from the room, we had to have an asbestos abatement team come and do whatever they needed to do, and then we moved our objects. So that was the case. I'm not sure if that answers your question.
Hopefully. Andrew asks, their museum has petroleum samples in the collection due to a connection with the oil industry. Do they present a danger to the rest of the collection through off-gassing? And how can they mitigate that?
Oh, that's a very wide question. Yes, off-gassing might be a problem for some objects and needs to be assessed. It needs to be what type of chemicals are off-gassing needs to be determined. And the objects, what materials have the objects are in, so what condition the objects are in, also important. And how are they separated or together kept needs to be known in order to assess the problem, basically. And yes, petroleum products off-gas.
So Andrew, that might be a great one to follow up with a conservator, either with Özge or with a local conservator, to speak about the best storage options for that.
Or assessment, basic assessment, to see what needs, what is urgently need to be removed from the room, or if there is any emergency. But the petroleum definitely off gases. It's products off gases, like plastic, some plastics and other things. So it will definitely off gas some sort of chemicals.
And he's put a comment in that they're actually raw samples of petroleum.
Oh. Yeah, consult a conservator, and we'd be happy to help. Depending on where you are, I'm sure you'll find a conservator. All conservators I met, they're passionate about their work. They want to help.
Everyone has something in their collection that's just a little bit different.
Yes, yes,
it really helps.
That's the most interesting part of my job. Not all questions are the same, and not all answers are the same. It's just finding ways to mitigate.
Well, if anyone has any more questions, put them in the chat. I had one question earlier on. You mentioned bacteria being more common on archaeological sites. And so I was wondering if there are certain types of objects that would be more likely to retain the bacteria.
Bones. Yeah. Yeah, burials. I mean, if wood and textile were preserved, maybe in them too, but mostly burials.
I wouldn't have thought about that.
And sometimes they may grow like bacteria. In one site that I was working in Kaman, Kalehuyuk, in Turkey, it's a Japanese institute, and they usually have state-of-the-art depots and everything. But in their depots, the burials that they found started growing bacteria, those like red, like alarming bacteria was growing in. So we weren't allowed to go into the storage areas until they resolved the issue. I don't know what they did, but it was a problem. So it can grow later on also, not the specific bacteria that was found during excavations, but like bacteria later on can grow.
Do you have any thoughts about punctured MRE kits, meals ready to eat?
I'm not sure about MRE kits. I don't know. I don't know what those are.
It could be a mold source as well, since it's food, but perhaps another one for a little bit more detail. But since I don't see any more questions, I'm gonna share my screen real quick again. And first of all, thank you again for this incredibly informative presentation, Özge. I just wanted to make sure to announce our next webinar, which will be on Thursday, January 20th at 10 a.m. Pacific time. And we'll have Fran Ritchie of the National Park Service's Harper's Ferry Center talking about care and cleaning of taxidermy. So some of these same things that we've talked about, the hazards that are in the collection, well, now we're going to talk about how to safely clean them. That's
perfect.
It's a good transition.
Yes.
So I am just going to quickly press send on the link to register for that in the chat. Go ahead and register for that one right now. And then I'm putting back up on the screen here both my contact information and Özge's. If you have further questions about today's subject, she is the subject matter expert here. Don't send those to me, send them to her. But if you have questions about the Registrars Committee Western Region or this webinar series, I would love to receive those emails. So rcwrvicechair@gmail.com. With that, I will go ahead and end today's webinar. And we thank you so much for joining us and look forward to seeing you in January. Thank you, Özge.
Thanks for listening.